This is part 2 where we are doing our project. Uh, it's called Roof, and it is a museum which located in Abu Dhabi. So last part we were here. So I went ahead, finish all steps, but I'm going to break down what I have done so far. So let's recap. Um, First of all, we have print our point from cars. So after bringing our point into inputs, we made our function or method. The method was taking points, list of points, and make a grid which formed this grid you see. And if you haven't seen my first video, I highly recommend you to go back and watch that video and come back here so you understand more. So after we got grid points, um, uh, we found the z height of each point required to form a dome where we used Pythagorean theorem. So after getting those points in 3D which forming crowd of dome, uh, we made interpreted curve which uh, formed our pattern, which is similar we have to museum of Louvre. Then the tricky part was to offsetting this curve after we getting them in 3D. So there was no easy way for offsetting the curve according to my knowledge. Or yeah, I can say according to my knowledge, but I figured out another way. Maybe there could be another way, but I found the problem was required different plane uh, which offset with based on. But I found the other way. So what I did, I had those point forming curves in wrist in order. I made polar line, which I can extract. I can get center points. After getting center points, then let me sketch what I did after the offsetting. So imagine we take our triangle, for example, we take on the triangle, for example, we have this triangle, let's use an about the sketch. Then we found the center point. After we found the center point, we made a line. After getting that line, we made another point which defined by our t value or parameter, which are this, which can slide over to the line. So it's end up creating offset as you see. So that's what I did. So let me show you in a video code. And after we got our center line, uh, we went ahead and divide our point with t value we have. This after making the line at middle, this red line, we we found a point on the curve or on line. Then that point we added in wrist. So because we have the same line number as the same way we have it in the list of points which made our curve. So we end up having offset of this curve. And after getting that point, we need to interpret the curve again, so we get second curve which are offset. So uh, this part, I was checking if the curve is cross or not. Either the first curve we had and the second one we did for offset to make sure that all curve I have they are close. So here it's a simple statement that say if this curve is cross and second curve is cross, add them in a list. So that's what I did here. Um, I have two lists which I'm going to explain it after, but let's see our offsetted curve before anything. let's put our parameters, our parameter or t value, because here you can see we have 0. Let's put this value. You can see I have offset, which I'm able to control anywhere I want. So after getting this offset, what we have to do was to loft, so that we have uh, our billet faces forming this dome. So let's see what I did after. So after adding those line here, after adding those line here, I made another list of setting. Uh, I made two lists, for one for lofting, another one for keeping our curve. So I was want to make two lists which going to perform two lists. So one list was return return type, but another list was supposed to give us loft. So the loft, there is a method in common, like not common, which creates build up from the building curve or loft. Simply call it loft. So after lofting, you get build ups. They come in arrays. So here the simple statement I did, I made for each row, and I made statement if the b, which build ups I'm getting from loft, if it is none, don't take it. So I here simple statement making sure that I get my build ups in a list. So after that, I I got my build ups, which you can see. These build ups, I have power of setting because it is C sharp. It is not heavy, or it's not heavy for calculation. You can see I can change it anytime I want. Either kind somehow make it full. So uh, next I want to show you how I I cut all build ups to get a clear project the same way we have it. As you saw, we have um, uh, as you saw it, we have a circular dome, which are on the top of them. Instead of to have a whole dome, we have 1/8 of the dome. Yeah, we have a small part of the dome on top. So next what we have to do also, it is to cut all build-ups so that we get this shape you're seeing here. Let's decrease our offset. 0.5 for example. It's enough. Okay, after that, here what I did for cutting all build-ups, trim all build-ups. Uh, was to go in every branch. I made simple loop. First of all, I did the tree of all cutted build-ups. All build-ups was cutted or trimmed, um, and I took all my build-ups I had, so that I can cut each single build-ups. So this loop is simply nested loop, which we we have the number of branches as first loop, and second nested loop which we keep looking in each list so that we find the beat-ups we need to cut. And here we have a simple method help us to cut our beat-ups, which you can find in Rhino Common. After getting our cutted beat-up, we added in the list or tree we created first. Those three with all cutted beat-ups, which we added from here. So let's see. Um, you can see all beat-ups we cut. We have it here. So next step is sort of to make sorts so that we take beat-ups we want and the one we don't want we left it. So that's our next process. But before, I made a visual cycle to see what we have cut so far. You can see if we go to elevation, this is like plane we use it to cut so that we get the top part. So the curve is there for visual only to see the center part of our plane we use it to cut. So let me go back show you the plane I created for cutting our build-ups. Here, um, first of all, I found the step of grid and find the center point, which I did it also method. It's the same things I did here, which I made copy of there so that we got the center point. After getting center point, um, center point of all grids, we form a line. This line was to determine the radius the same way we did it in method, if you remember, so that we can get our curve. So we can get radius of our curve for visually only. But the plane is supposed to use it for cutting. It is this one which have the same center point of um, of our center of circle. So the center of circle is simply what we did, because if you have the center, we was want to have a center point of circle at um, 180 of the height of radius, 0.7 for the radius, 0.75% of the height of radius. So that's the center of the plane which we want to cut for our bearings, which you can see it in viewports. So after defining our center point or plane, so simply we went through to the branches and we found the appropriate bearings we need to cut in order to trim the bearings. So this part after it's done, I need another script we see on the Grasshopper itself, which even I can do in C sharp, but it's more easy here in Grasshopper um, than to do it in C sharp. So as you see, what I did here, um, I simply took my beat-ups. This one no longer needed. Simply took my beat-ups, finding bounding box for each beat-ups. After finding the bounding box of beat-ups, found centroid. This centroid will help me to get the centroid of each each beat-up here, so that I can decide which beat-up I have to leave and which beat-ups need to stay. I need to take. So and again I made this component called the list, What simply does, it's gone to each branch and found that the number of items. So those number of items are used to divide my circle so that I will compare the z direction, I z height for each perhaps centroid here. So because this length is giving the same branches as as we have it from B-Labs, so it's kind of matching so that we can um, get z coordinates and compare the height. Here it's simply when our B-Lab centroid has the z value over than uh, the z value of circle with point on circle. This amount of this point equal the amount of B-Labs we have here. So simply if the z coordinate is greater than by the B-Lab centroid, we take those B-Labs which you can see here. So, as you remember here, we have a list of B-Labs which we cut it through. So also we need to do the similar process so that we remove the, this cutted plane or the cutted B-Labs which are out of the boundary of circle. So the same things we've done. We divided our curve, this one, with equal point number as the same beat-ups we have. So here we have uh, this number which I did a mistake. We have 144 of these beat-ups we cut from our brain. So what we was looking for here is the uh, points or centroids of our beat-ups which are over to our curve. So also we took our z coordinates, we compare uh, to a centroid with point on curve. Simply also we got beat-ups we wanted which are over to the curve. So here we end up with small truths, but it's okay for small truths. We can keep doing this process up to the level we become certified. Here I added simple level of control, which I can either increase it or decrease it. So here you can go ahead and figure out the pillars which they are aware of the boundary circle. So it is easy processing. I want to stop here so that I leave it for you to finish on your parts. But most part, I think we have covered all important stuff we were supposed to do. So this is it. Thank you for watching this video. Subscribe to our YouTube channel, share and like. And these scripts I will link down to description below so that you can refer to it and go through it so that you can learn something. And if you have suggestions or any ideas for things I have to improve, just comment down. I will be happy to read it and answer. Maybe next time I could try to correct it also. So thank you so much. Um, Last part, let's see what we've done so far so that we can enjoy our project. Let's put on rendering codes so that we see our project. So what we've done so far. Here, uh, another part I did for Grasshopper, which was adding these traces, which another part of this video or next video I'll show you how you can make these traces. Then simply here As I explained at the beginning, layers. We have layers of domes. So here we have four layers. As the same, the bottom part, we have another layers. So if you are seeing from down, you can see this dome, which each layers is rotated 45 degrees. So I think this part is easy, very easy. We can mix our domes or screen with different strokes. So as we saw, we have power of deciding the loft we want. If we want our screen to be closed or open, so we have that type of control. You can go ahead and finish it. On next part, I will try to do this project within Grasshopper, but it's kind of heavy, so that's why I avoided those processes of doing it in Grasshopper. But next time I will try to perform it in Grasshopper itself without using any programming language in C Sharp. Thank you so much, and remember to make a comment down there and check all this all these projects, all what we have done, and addition of this Rhino file. You will find it in the description below. Thank you so much. See you next time.